Hello and welcome as we meet again to study inventory models. Now in previous lecture we talked about these two models, purchase model without shortage and manufacturing model without shortage. Today we'll advance our discussion to our next questions. So the question that we have over here says that annual demand for an automobile component is 24,000 units. Annual demand is 24,000 units. So we can say that it is 24,000 units per year, annual demand, because they are calling it annual demand, so it means it is per year. Then we have ordering cost of rupees 20 per order. Then we have carrying cost of rupees 0.1 per unit per quarter. Then there is a shortage cost of rupees 1 per unit per month. And then it is find all relevant parameters. Now first thing is we need to find out which model is this, and second thing would be what are the relevant parameters. So first thing is, let us go ahead and try to find out what model is this. What model do you think this would be? Do we have a production rate? Because we do not have a production rate, so definitely it cannot be manufacturing model, because both of these manufacturing models make use of production rate. Both these models make use of P. Because there is no P, it cannot be 3 and 4, third model and fourth model. Because we have shortage cost, so obviously it has to be either of these, because these are the only two models which are making use of shortage, because S is given. So what model can this be? It is not possible to have this model because we do not have P. It is not possible to have this model because we do not have P. It is not possible to have this model either because we have a shortage cost. But this model makes no use of shortage cost. So definitely this is my model. EOQ 2AO upon C, C plus S upon S. This will be my model. What is second model? It is purchase model without shortage. Obviously when there is no production cost, it has to be purchase model. And obviously when there is a difference of shortage cost, so it is purchase model with shortage cost. And what are the relevant parameters for this model? If we try to find out relevant parameters for this model, first let us make this model and then we'll try to trace all those relevant parameters. What do we have? We have quantity, we have time. Then because it is purchase model, so there is instantaneous replenishment. This is the model. We have T, then this cycle is split into two. We have a T1 and a T2. Then there is Q1. This is the level where we are going down, up to which we are going down. This is Q2. And the complete swing is Q. Remember, Q1 is the maximum inventory level, Q2 is the minimum inventory level, while Q is the swing in inventory level. Swing is from minimum to maximum. In previous models, it was from 0 to whatever level we were touching. So Q1 and Q were equal in previous two models. In previous question we saw. But this time Q is equal to Q1 plus Q2. And then what are the other models? Of course, we can say that EOQ is equal to Q. So we can start with our second model. Second model is this one. And what will be the remaining formula? We already have a formula for EOQ. What will be the formula for Q1? Q1 would be under the root 2AO upon C, and the factor gets reciprocaled. It becomes S, C plus S. This becomes Q1. So we have EOQ, EOQ will be equal to Q, and this is the formula for EOQ. So we have EOQ, Q, this is Q1, and remember what is Q2? Q2 is simply Q minus Q1. This is complete Q. If you remove Q1, you get Q2. So Q2 is simply Q minus Q1 is Q2. So we have EOQ, Q, Q1, Q2. Then what about T? T, as we know, it is always EOQ upon A. Then there is a T1 and T2 also. T1 and T2. T1. What is the quantity swing in T1? This is T1. When we start T1, the quantity is at this point. This point is Q1. So at the start of T1, my quantity is at Q1. At end of T1, my quantity comes down to 0. So what is the swing during T1? Swing during T1 is Q1. What is the swing during T2? At start of T2, at this point, quantity is 0. But when you come down to end of T2, you are traveling, you reach the end of T2. The quantity has dropped down to Q2. Remember, formula for time is quantity upon rate, if you remember previous lectures. So we have quantities for all rates. For T, complete time, it is always A, because we are always consuming whatever we need, because we are always selling whatever is the total demand. So for the complete time period, our consumption would be always A, at the rate of A. But in case of T1 and T2, it can be different. Yes, in this case, T1 is also A, T2 is also A, because we are coming down. Whenever we are coming down the graph, we are always coming down the graph at rate of A. If it were a manufacturing model, we would have gone up also. That is P minus A. But in this case, because we are coming down, then again we are coming down, and all the time we come down at rate of A. So these will be the formulae. Let us go ahead and find the respective values. What I would suggest is, you can pause the video over here. You have all the formulae over here. Go ahead and try to find these values by yourself. I'll try to find out all these values over here. So we'll have EOQ. EOQ is equal to under the root 2AO upon C. It is our second model, that is with shortage, purchase model with shortage. So formula would be C plus S upon S. Now the important thing is, this is per year, this is per month, this is per quarter. All the time frames are different. So we need to make adjustments. What will those adjustments be? Let this be at scale of year. This is per quarter. So 1 year has 4 quarters. If I multiply this to 4, I'll be getting it as rupees 0.4 per unit per year. This rate is per quarter, so I multiply it to 4. This rate is per month. If I multiply to 12, I'll get shortage cost as rupees 1 per unit per, sorry, not month, because we have multiplied it to 12. It will become 1 multiplied by 12, that is 12 per unit per year. 0.1 multiplied by 4, quarter getting up to the scale of year. 1 multiplied by 12 becoming 12, month upgraded to year. So these will be my carrying costs and shortage costs. Remember, the time frame should always be same. Yes, what you could have done is, you could have divided this by 12 to bring it down to month. You could have divided this by 3 to bring it down to month. Each quarter has 3 months. So if you are bringing everything down to month, this is already in month. Divide this by 3, it will come down to month. Divide this by 12, it will come down to month. And if you wish to take everything to quarter, divide this by 4, it will come down to quarter. This is as it is in quarter. And multiply this to 3, because we need 3 such months to make a quarter. Fine, so it is up to you. it is always suggested you go to year because it is a case of multiplication. Multiplications are always easier than divisions. Here what we did was simply multiply it to 4, simply multiply it by 12. Divisions would make these values smaller. And then because of our not so happy experiences with approximations and rounding offs, we might miscalculate these values. In any case, we have EOQ is equal to these values. Now, can we substitute all these values? 2, demand is 24,000. 2A, ordering cost is 20 upon C. C would be 0.4 multiplied by C plus S. C is 0.4, S is 12. 0.4 plus 12 upon 12. Let us go ahead and solve this. You can pause the video, you can find out all these values by yourselves and then we'll tally it over here. And I'll solve it over here. So I get 2 multiplied by 24,000 multiplied by 20 is equal to this divided by 0.4, giving me 24 lakhs. This is 24 lakhs. And the next figure would become 12.4 divided by 12, making it 1.033. 1.0333 under the root. This is not add, this is rather multiply. Multiply it to 24 lakh to get 24,799,999. 24,799,999. And if I go for the square root, it comes as 1574.80 units. So this is my EOQ. And incidentally, it is also equal to Q. So I have my EOQ and Q. Let me go for Q1. What is the formula for Q1? It is 2AO upon C. Let us make use of some other color because these will be long calculations. So it is better we make use of some other color. What is this? We are talking of Q1. Q1 is 2AO upon C with this factor getting reversed, reciprocaled, C plus S. So I will be getting 2AO upon C multiplied by 12 divided by 0.4 plus 12. This factor getting reciprocal. And then we have this complete value is coming down as 24 lakhs. And this factor would be 0.9677. 0.9677. And if I see 24 lakh, then it is 23,22,580. 23,22,580. 0.64. And if I take the square root, it will be 1524. 1524 units. Fine. So we have EOQ, we have Q1. We have EOQ, we have Q, we have Q1. What is Q2? Q2 will be Q minus Q1. Q2 would be Q minus Q1, making it 1574.8 minus 1524, making it 50.8 units. So the shortage that is permitted, the shortage that we are exploring, the shortage we are exploiting is 50.8 units. Let me just check 1574.8 minus 1524 gives me 50.8. So I have all the quantities. I have EOQ, Q, Q1 and Q2. Then remains 3 times. Let me make use of some other color once again. It will be T is equal to, T is always EOQ upon A. T1 would be Q1 upon A and T2 would be Q2 upon A, giving me T is equal to EOQ is 1574.8 divided by 24,000. Now let me multiply it to 365 directly, because what we'll get is years, which is very small, which is not understandable easily. So we have 1574.8 divided by 24,000 multiplied by 365. We get 23.95 days is equal to 23.95 days. Why have we done this multiplication? So that these years get converted into days. Why these are years? Because we have taken everything on a scale of years. If you had divided this by 12, if you had divided this by 3, everything would have been on a scale of month. In that case, I would have multiplied it to 30, not 365, because a month is 30 days long. So this is my T. Then we have a T1. T1 would be Q1. Q1 is here 1524. 1524 upon 24,000. Again, let us multiply it to 365. So it will be 1524 divided by 24,000 multiplied by 365, giving me 23.1775 days. And finally, we have T2. T2 is Q2 upon 8. Q2 would be 50.8 upon A is 24,000. 50.8 divided by 24,000, making it, sorry, let us multiply it to 365 also, making it 0.77 days. Now, complete T should be summation of T1 and T2. So I have T1 as this. What is T2? Plus 23.1775. I get 23.95 days. So yes, EOQ, Q, Q1, Q2, all values are correct, because T1 and T2 added are becoming T. So this was our second model. In previous lecture, we talked about first and third model. This was our second model. And now let us start with our next question. The question says, demand for an item is 18,000 per year. So the demand is 18,000 units per year. Then additional information given is its production rate is 3,000 units per month. Production rate is given this time, which is 3,000 units per month. Then there is carrying cost. Carrying cost is given as rupees 0.515 per unit. Per month. And then there is shortage cost, which is rupees 5 per unit per quarter. And then finally we have an ordering cost or setup cost, which is 500 per setup. Now, question says, find various parameters of inventory system. Find various parameters of inventory system. So this is the scenario. Now, first of all, let us find out what model is this, and then we'll see what can be the various parameters First of all, we need to identify what model we are talking of. Then only we can plot the graph for it, and then only can we go for various parameters of the inventory systems. Now, which model this would be? We have production rate. As soon as you get production rate, it has to be either this or this. There is no possibility of it being second or first model, because I have a production rate. Production rate is used in only these two models. These two models do not make use of production rate. So definitely it is not first two. So it is not a purchase model, it is definitely a manufacturing model. Also, I have a shortage cost. So for shortage cost, it can only be this. This is not making use of shortage cost. There is no mention of shortage cost in the EBQ formula. So with given information, I can ascertain that my model is the fourth model. I'm not with first model, second model or third model. My model is the fourth model. And now that I know that I am dealing with my fourth model, can I go ahead and plot the fourth model? Fourth model is manufacturing with shortage. It goes like this. It is manufacturing, so it rises slowly. It is not instantaneous replenishment. In purchase models, it was instantaneous replenishment. But in manufacturing models, it is always a slow rise. And this rise is with the rate of P minus A. And this decline is with the rate of A. Again, you are going ahead with P minus A, you are coming down with A. This becomes handy. This comes handy with T when we are calculating values of time. At that time, these rates come in handy. So we should be knowing that whenever we go up with the rate of P minus A. Whenever we come down with the rate of A. So here we have this model, and because it is shortage, so it will go beyond excess also. And this can be our one complete cycle. So we have a T for complete cycle. Then if we see, there are 4 segments. We have a T1, we have a T2, there is a T3, and finally there is a T4 also. So we have T1, T2, T3 and T4. What about quantity? We have a Q1, then there is a Q2, and there is no relation between Q1 and EOQ or EBQ. There is no relation between Q1 and Q2 with EBQ. But yes, there is a relation of Q. There is a relation of Q definitely, but there is no relation otherwise with EBQ. So what will be the formulae? We will write down the formulae there itself while we are solving it, okay? Because this time we do not have much space over here. So we will write down the formulae as we come across them. First thing would be EBQ. Because this is a manufacturing model, we will be having EBQ. EBQ would be exhaustive, everything coming here, 2AO upon C. Then being a shortage model, it will be C plus S upon S. Then being a production model, it will be 1 upon 1 minus A by P. Everything is coming over here. So what will be the values? 2. One more thing. We missed this thing. This is per year, month, quarter. Everything is in all directions. So let this be in year. We'll convert this also into year. So what I can do is I can multiply this to 12. Multiplying it to 12 would give me 36,000. 12 threes are 36,000 units per year. So production rate has been converted into year. This is also month, this is quarter. Now month, I need to convert it into year. Multiply this to 12. Multiplying this to 12 would give you 1.8 rupees, 1.8 per unit per year. So this has also been converted into year. Taking quarter to year would be multiplying it to 4. 5 multiplied by 4, would give you rupees 20 per unit per year. This is setup, so it is not in time frame. In the domain of time frame, we had production rate, carrying cost and shortage cost per unit, per month, per unit, per quarter, per unit, per year. So we have converted everything into year. This is year, this is year, this is year, this is year. Everything is in year. So 2, annual demand is 18,000. Ordering cost is, setup cost is 500. Then we have a carrying cost. Carrying cost is 1.8. Then next factor, C plus S upon S. C plus S, that is 1.8 plus 20. 1.8 plus 20 upon 20. C plus S upon S. Then finally there is a factor of 1 upon 1 minus A by P. A is 18,000 and P is not 3,000, it is 36,000. If we had not converted it, we would have made it 18,000 by 3,000. But now we know that it is 18,000 and 36,000. So we have 18,000 and 36,000. Now can we go ahead and find the values? The values would be 2 multiplied by 18,000 multiplied by 500 divided by 1.8, giving me 10, this is 1 crore. Giving me 1 crore. Let me check. 3 and 3, 6 and 1, 7. 1 crore. Next factor would be this one. 21.8 divided by 20, making it 1.09. Finally, we have this factor. This would be 1 upon 1 minus 0.5, making it 1 crore multiplied by 1.09. So it will become 109. This will be 0.5, so making it 2. Multiplied by 1 crore multiplied by 2, and then going for under the root. 4669, giving me 4669.047 units. So my EBQ is 4669. Next would be, we are through with EBQ, fourth model. Next would be Q1 and Q2. If we add those, we will get Q. What will be the formula for Q1? Q1 is, these factors get reciprocaled. So I will be having 2AO upon C, S upon C plus S, 1 minus A by P. If we find out values, it will be 2 A O upon C. Then this is reciprocal, so it becomes 20 upon 1.8 plus 20, and this becomes 1 minus 18,000 upon 36,000. Resulting in this was 1 crore. This is 1 crore. Next factor would be 20 divided by 21.8. Sorry, 20 divided by 21.8, making it 0.9174. 0.9174. And this factor would be 1 minus 0.5, making it 0.5. Multiplied by 0.5 multiplied by 1 crore, making it 4587155.96. 4587155, 4587155.96, and then going for the square root 2141.76 units. So my EBQ would be 4669 units. My Q1 would be 2141 units. And now let us get on with our Q2. What is the formula for Q2? I'll change the pen so that we have different colors and they do not get mixed up. Formula for Q2, if you remember from previous lectures, it was 2AO upon C plus S 1 minus A by P. Remember, these C and S would switch their places. This is the formula for Q2, if you remember it from our previous lectures. So if we go ahead and solve this, it will be 2AO, sorry, we need to put the values now. 2AO upon S this time. S is 20 multiplied by C. C is 1.8 upon C plus S, 1.8 plus 20. And then we have 1 minus A by P as it is. 1 minus 18,000 upon 36,000. If we go ahead and solve it, it will be 2 multiplied by 18,000 multiplied by 500 divided by 20, making it 9 lakh. 9 lakh. Next factor would be 1.8 divided by 21.8, making it 0.08257. And last factor would be 0.5 multiplied by 9 lakh multiplied by 0.5, giving me under the root 37155.96, and the square root would be 192.76 units. So I have my EBQ, Q1 and Q2. We have EBQ, the economic batch quantity. We have Q1, we have Q2. If we add these Q1, Q2, we will get Q. Let us switch the pen once again. Q would be Q1 plus Q2. Q1 is 2141.76. Q2 is 192.76 plus 2141.76. 2334.51. 2334.51 units. So now let us move on to all the times. We have Q1, Q2, everything is done. Let us move on to times. I'll put the formula over here. T would be EBQ upon A, and of course we'll multiply it to 365 because we have less space over here. I'll make all the calculations over here. Remember, we'll always be making it multiplied by 365 so that it gets converted into days. Otherwise, we'll get it in years. Okay, so then T1 would be T1. T1 is this Q1. We start at 0. During the period T1, we start at 0, we reach, by the time we come to the end of T1, we start at 0, by the time we come to the end of T1, we have reached to Q1. So it will be Q1, and when we are rising, we rise at rate of P minus A. Then what about T2? T2 we start at level of Q1, and by the time we come to the end of T2, we are at 0. So it will be Q1, but this time in the denominator we will be having A instead of P minus A. When we rise, we go up with P minus A. When we come down at a rate of A. So we have T1, T2, then there will be T3. T3 is this section, small section. This will be Q2 upon A because we are still coming down. And finally, T4 would be Q2 because we are rising. This is the T4 section. We are rising and we are rising by this amount, that is Q2. But whenever you rise at rate of P minus A. And of course, all these will be multiplied to 365 in order to get days. So let us start over here. T would be EBQ upon A. EBQ is 4669.04 upon A multiplied by 365, giving me, why am I multiplying it to 365? So that I get in days. 4669.04 divided by 18,000 multiplied by 365, giving me 94.67 days. 94.67 days. Fine. Then let me find out T2 over here. Sorry, T1. This was T. Let me find out. T1 is Q1 upon P minus A. Q1 is 2141. 2141.76 upon A. A is demand 18,000. Sorry, T1 is P minus A. So it will be 36,000 minus 18,000 multiplied by, of course, 365. So this will be 2141.76 divided by 18,000 is equal to this multiplied by 365, giving me 43.43 days. 43.43 days. Why days? Because I have multiplied it to 365. Then we have T2. T2 is Q1. Q1 is 2141 again. 2141.76 upon A. A is directly 18,000. Last time it was P minus A, but we got 18,000. This time it is directly 18,000. Multiplied to 365, giving me 43.43 days. So I have T, T1, T2. Let us have T3. T3 would be Q2 upon A. Q2 is 192.76. 192.76 upon A. That is 18,000 multiplied to 365, making it how many days? 192.76 multiplied by 365 divided by 18,000, making it 3.91 days. 3.91 days. And finally, there will be T4. T4 is Q2, this section, from 0 to Q2. Q2 is 192.76 upon, this time we are going up. When we rise with P minus A. That is 36,000 minus 18,000. Making it multiplied by 365 for days, making it 3.91 days. Now, if we wish to check if all these calculations are correct, what should we do? We should add T1, T2, T3, T4 to get T. Let me see. It is 3.91, then it is 43.43, and this complete is 94.67 or 68. So yes, T1, T2, 3, T4 are in perfect condition because they all are tied to each other. All T's are tied to EBQ, Q1, Q2, everything is tied to one another. And if all are making perfect sense, then we are in good shape. Then our calculations are correct. So this was our discussion on our fourth model, that is manufacturing model with shortage. With this, we conclude the basic models of inventory management. Next time when we meet, we'll talk about the price break models, quantity discount models. So this is it for our today's discussion. Until we meet next time, do take care. Thanks for watching. Bye-bye.